Okay, so as I said on the agenda, we are going to be doing the very beginning of Chapter 7 today because I want to be there answering any questions you have on Chapter 6. So we're just going to run through this so we don't lose any time today. Luckily, it's something we've done before, hopefully a little bit in middle school, and that is the Pythagorean Theorem. So Chapter 7 is all about triangles and how to find missing parts, and this is one of the methods that we've seen hopefully before, but maybe we've forgotten how it works. So we're just going to run through the very basics right now since I'm not here, just to refresh your memory. Okay, so Pythagorean theorem is basically this idea that in any, not any triangle, in any right triangle, the square of the hypotenuse, right? Hypotenuse, again, the hypotenuse is always the longest side of the right triangle, the longest side. And remember from chapter 5, the longest side is always opposite the biggest angle. So the biggest angle for a right triangle has to be the 90 degrees, right? So you can always find it by going opposite the 90-degree angle, right? It's always opposite the 90-degree angle, right? Because the biggest angle opens up to the longest side. Okay? The square of the hypotenuse equals the sum of the square of the legs, right? The square of the legs, A and B. So we call the hypotenuse C. We call the legs A and B. It doesn't really matter who you call A and who you call B, but the biggest one has to be this guy right here. So what it's saying is if I have a triangle, again, if it's a right triangle, this guy right here, this side, this is my A, this is my B, and this is my C, or you could put this be your A, this be your B, whatever. But if I square this number 3, that would give me 9. If I square this number 4, it gives me 16. If I square this number 5, I get 25. But if you add up 16 plus 9, you get 25, right? This plus this will give you this, right? A squared plus B squared would equal C squared, no matter what. Sometimes it works out to be nice whole numbers. Other times it doesn't. Okay, so identify as a leg or the hypotenuse. Find the unknown side. Write your answer in simplest radical form. So we're not going to use the decimal. We're not going to use a calculator. So if we look here, what is our x? Well, I see that it's opposite the 90 degrees, right? Opposite the biggest angle. So this has to be the longest side, right? This has to be my hypotenuse. Hypotenuse, right? This is my leg, and this is another leg. Okay, so again, you can call either one of these A, but this has to be your C. Okay, so again, we can just write, as always, we can write A squared plus B squared equals C squared. But in fact, I'm going to actually write it backwards, and you will see why when we do chapter 7 for real. Okay, so A squared plus B squared equals C squared. You can write it the normal way, but I'm going to write it with the C squared on this side, and that you're going to see why, again, after we finish chapter 6. So C squared equals A squared plus B squared, or you can write it A squared plus B squared equals C squared. So I plug in, okay, what is my leg? It's 6, so 6 squared. What's my other leg? That's 8. 8 squared equals C squared. And then from here, it's just algebra. Right? 6 times 6 is 36. 8 times 8, 64, equals C squared. I combine like terms. 30 plus 60 is 90. 6 plus 4 is 10. So 36 plus 64 is 90 plus 10, or 100. Okay, so C squared equals 100. Now, how do I get C by itself? Again, how do I undo a square? Right, it's not dividing by 2, right? That'd be, to undo multiplication, I divide. To undo addition, I do subtraction. To undo a square, well, what's the inverse of squaring? It's not dividing, it's square rooting. So you have to square root both sides. Okay? So the square root of C squared, these just kind of, they're inverse operations, they undo each other, so we just get C. So C equals the square root of 100. Square root of 100. So what number times itself gives me 100? From algebra, we learned there's actually 2 numbers. It's plus or minus 10 is the correct algebraic answer, right? Because whenever you square root both sides, in algebra we learn you put a plus or minus because 10 times 10 gives you 100, but also negative 10 times negative 10 gives you 100. Okay? Now this would be the correct answer, except because we're in geometry, we're dealing with actual lengths. We can't have a negative length, so we don't worry about the negative, so we just say C equals 10. Okay? So notice here, just like with this triangle here, 3, 4, 5, this was 6, 8, and 10. Okay? So some of these guys, some of these triangles are the side lengths are going to be perfect whole numbers, right? So for example, 3, 4, 5, that's a very common one, right? 3 squared plus 4 squared plus 5 squared. Another one is 6, 8, 10, right? 6, 8, 10. So anytime where all three are whole numbers, I call this a Pythagorean triple. Just to let you know about that term. We'll talk more about that in chapter 7, Pythagorean triple. Not everything is a Pythagorean triple, okay? So for example, this guy right here, it's not going to be a whole number. It's not going to be a Pythagorean triple. So let's see how this works. Letter B. Okay, so again, what's missing? I go here opposite this x. That's the biggest angle. This is the hypotenuse. Right? Hypotenuse. So again, this is my C. It doesn't matter who I call A and B. So I just set up again a squared plus b squared equals c squared, or just write it backwards. Either way, c squared equals a squared plus b squared. So I don't know what this is. I guess I should have plugged in x over there, but whatever. I'll go with 6 is my a and 4 is my b, or you could swap them, it doesn't matter. So 6 times 6 gives me 36. 4 times 4 gives me 16. Okay, so let's think about this. If I add these up, 36 plus 16, so 30 and 10. 30 plus 10 gives me 40. 6 plus 6 gives me 12. So 40 plus 12. 40 plus 10 plus 2, 52. So x squared equals 52. Okay, so to find what x is, the hypotenuse, again, to undo the square, I square root both sides. So my answer is plus or minus the square root of 52. Plus or minus the square root of 52, but again, since we're dealing with side lengths, we don't go with the negative. We just say the answer is square root of 52. Okay? Now remember, I said to write it in simplest radical form. We learned how to reduce radicals in chapter 1. As a quick review, there's 2 ways we can do it. Method 1, just break it down into its prime factors. Okay, so you would draw like a factor tree or something like that. I'm kind of running out of space, but let's see, 52, I'll just draw a factor tree. 52, let's see, what would that be? Well, it ends in a 2, so I know it's an even, so I can multiply by 2. 2 times what gives me 52? Well, 2 times 25 gives me 50, so another 2, so 2 times 26 has to give me 52. I could break down this into 2 times, let's see, what would that be? 13. And so this is prime, this is prime, this is prime. So prime factors, I could write square root of 52 as 2 times 13, right? That's the same as 52. And what this does, it helps me to see that, hey, anytime I have a repeated factor, that's a perfect square. So I could see, oh, that's actually just the square root of 4. I can put that on the outside, and I get 2 root 13, right? 2 root 13. Okay. The other way, method 2, if you don't want to do this, if this is too long for you, method 2, you just look for perfect squares. All right, you just look for perfect squares. Look for perfect square factors. Right? Perfect squares, again, are like 4, right? 2 times 2, 9, 3 times 3, 16, 4 times 4, 25. And so if there's any perfect square factor of 52, you can rewrite it. And in fact, there is, right? Because 4 times 13 gives you 52. So I could rewrite square root of 52 as the square root of 4 times the square root of 13. Right? So if you didn't want to break it all the way down, you just say, hey, 4 times 13 gives me 52. And what do you know? Because this is a perfect square, right? Square root of 4, so that's just 2. I can rewrite that as 2 root 13. Okay, so either way, you can break it all the way down or just look for perfect square factors, but we get 2 root 13. All right, once you pause the video, go ahead and try letter C on your own. Okay, so if we look here, this is our hypotenuse, the longest side. So this is actually just a leg. This is a leg. So if I go c squared equals a squared plus b squared, this time I do know my hypotenuse. It's 5. It doesn't matter who I call a and b. I'll call this x. I'll call this 3. All right. So I get 5 times 5 is 25. It's x squared plus 9. So this time I got to actually do a little bit of algebra. Subtract 9 on both sides. So I get x squared equals 16. X squared equals 16. Okay, so I undo that by square rooting both sides, right? That's the inverse of squaring. And so I get x equals the square root of 16, which algebraically is either positive 4 or negative 4, right? Plus or minus square root of 16, or plus or minus 4. We throw out the negative. So we get our answer is just x equals 4. X equals 4. Okay? So again, this is 3, this is a 4, and this is a 5. And so if you started paying attention, you realize that this is actually a very famous one. Again, this is called a Pythagorean triple. 3, 4, 5 is the most common. So if you see 3 and 4, you automatically know this is a 5 as long as it's a right triangle. Or if you see 4 and a 5, you know that has to be a 3. The second most common one is 6, 8, 10. So if you ever see a Pythagorean triple, you don't have to show the work. If you see 6, 8, from now on you can just say boom, 10. Or if you see 3 something 5, you know that something has to be 4 as long as it's a right triangle. Okay? Again, we'll talk more about Pythagorean triples when we do actually do chapter 7. Okay, so let's look at number 2. Why don't you go ahead and pause the video, see if you can figure out which answer would this be. So you have a 16-foot ladder. Where would the 16 go? The base of the ladder is 4 feet away. Where does the 4 feet go? How high above the ground is the top of the ladder? That's x. Where does the x go? Which one represents how high above the ground it should be? And what is our answer? Go and pause the video, see if you can do it. Okay, so if we look here, if you did it already, let's go and take a look. The ladder is 16 feet, so that would have to be this length right here, 16 feet. Okay, the base of the ladder is 4 feet away, so that would be this length right here. The bottom, the base, is 4 feet away from the house, 4 feet. So how high above it is the top of the ladder? That would be our x feet. Right, so again, what do we have here? We have a right triangle, right? You see the right triangle. You have 2 numbers out of 3. And this is what I want you to start thinking about for chapter 7. Anytime you have a right triangle, you know 2 numbers, you just have to find the third. You can always use the Pythagorean theorem, right? C squared equals A squared plus B squared. So let's go ahead and think about, okay, this is our longest side, right, opposite the 90 degrees. This is our hypotenuse. These are our 2 legs. It doesn't matter which is which. So we're just going to say C squared equals A squared plus B squared. So 16 squared equals x squared plus 4 squared. Okay, 16 squared. So how do I do this if I don't have a calculator? You could do it the old-fashioned way, 16 times 16, and kind of go from there. I really like the area model. In other words, if I have a block like 16 by 16, this area, if I multiply these, would be the answer. So what I could do is I could decompose 16 into 10 and 6, right? 10 plus 6, 10 plus 6. And if I break it down this way, it's actually much easier than to just find 16 times 16. So if I think about 10 times 10 gives me 100. 10 times 6, 60. 6 times 10, 60. 6 times 6, 36. And so if I just add these together, it would equal the same area. So I can even kind of do this partially in my head. 60 plus 60 is 120. So the total would be 100 plus 120 plus 36, right? 100 plus 120 plus 36. So this is 220 plus 36. So 220 plus 30 plus 6, so that's 256. So this is 256. Okay, so 16 squared is 256 equals x squared plus 4 squared. 16. So we subtract 16 from both sides. Get x squared equals 240. Now, you might be tempted to pick letter A, but again, this is x squared. So I just square root both sides. Now again, let's say we don't have a calculator. We know the answer is not A. Let's say I don't know what the square root of 240 is. Which one of these is it? Look at this as your hint, if you didn't have a calculator. Let's see, I know that square root, so 20 times 20 times 20 gives me 400, right? 20 times 20 gives me 400. So that means the square root of 400 equals 20. The square root of 400 is 20. This is not square root of 400, so this is not it either. So the question is it 16.5 or 15.5? Here's your hint. Think about it. If 16 times 16 is 256, that means the square root of 256 is 16. Square root of 256 is 16. This is smaller than that. So it cannot be 16.5 since this is 16. This has to be less than. So this has to be 15.5. 15.5 feet. Okay, so sometimes you have to use a little bit of logic to go with these. All right, let's flip over to the back page. So we can also use the Pythagorean Theorem, and we will in Chapter 7 a lot, to help us find other parts of our answer. So find the area of the isosceles triangle with side lengths 10, 13, and 13. So see if you can draw an isosceles triangle. Where would the 10 go and 13 and 13 go? And see if you can find the answer. Go ahead and pause the video. Okay, so go ahead and, if you tried it, let's take a look. I'm going to draw an isosceles triangle. It does not say a right triangle. It's not a right triangle. So I'm just going to say tick, tick. So this would have to be 13 meters. This would have to be 13 meters. 10 meters. Okay, so this is kind of tricky, actually. How do you find the area of a triangle? Area equals 1/2 base times height. Right back from chapter 1. Do you remember the requirement for base and height? Base and height had to be perpendicular. Right? They have to make 90 degrees. This is not a base and a height. Right? This is not perpendicular. Okay? So again, we're not stuck though. All we have to do then is just draw it in. Just draw it in. So just draw in your height. Draw it in. Okay, that's your height, h. Okay, so if you didn't get it before, see if you can pause the video, see if you can figure out now. What's the area of this whole red triangle? Okay, so if I split this up, this would be 5 meters. 5 meters. I could just use this right triangle here. I can use this right triangle here, and what I have is I have 13, 5, and x. 13, 5, and x, or h. So this is my c, so I can say c squared equals a squared plus b squared. 13 squared equals x squared, so x squared plus 5 squared. So 13 times 13. Again, if you're not sure, you could draw a little box. 10 plus 3 times 10 plus 3. Or you could do it conventionally, of course. So this is 100, 30, 30, and 9. Right? 30 plus 30 is 60, so we have 169. 169 equals x squared plus 25. Subtract 25 from both sides. Get x squared equals 9 minus 5, 4. 6 minus 2, 4. So x is going to equal the square root of 144. So that is going to be plus or minus 12, or in our case, just 12. Done? No. Remember, I didn't actually find the answer. I just found this, h. This is 12. 12. Okay, so let's go ahead and just plug in 1/2 base. Right, base and height have to be perpendicular. So who's perpendicular to this guy that we just found was 12? Not the 13, it's the 10. So our base is 10, and our height is 12. 1/2 base times height. I can multiply these in any order I want. I could do 1/2 times 10 times 12. I could do 10 times 12 first, and then half that. Multiplication is commutative, it doesn't matter. I'm just going to half the 10, so that's 5 times 12, or 60. Oops, ran out of space. 60. So our answer is 60 meters squared. 60 meters squared. Okay, so again, the key lessons for today, just remember c squared equals a squared plus b squared. C is always the hypotenuse, and sometimes you can use it to find missing pieces. We can just leave these. We'll talk more about Pythagorean triples and stuff like that. We'll leave this for chapter 7, but I just want to get that done and out of the way. Okay, that's it. Oh, and I forgot. Please keep this. Right. Well, this will be page, I don't know, 3 or 4 or something like that. So I haven't made the chapter 7 binder yet, but just please keep this in your binder, and we'll organize this as soon as we are done with chapter 6.